So we have seen that we can solve GCD of A and B using the time complexity minimum of A comma B, right? Of minimum of A comma B. Can we optimize this? So we can optimize this how? Using an algorithm called Euclidean algorithm. Euclidean algorithm. What this algorithm says is basically GCD of A comma B is equals to GCD of A minus B comma B. Given that A is greater than B, which basically means that this number will be always positive, right? When A is greater than B, greater value minus smaller value, right? So using this formula, we can solve the problem. So let's say 4 and 10 is given. Let's take some big numbers. Let's say 38 and 6 is given. So let's say 38 and 6 is given to us. So GCD of 38 and 6 will be GCD of the difference and 6, right? So what is the difference? 38 minus 6 will be 32. Again, GCD of 32 comma 6 will be GCD of 32 minus 6, that is 26 comma 6. This will be equals to GCD of 26 minus 6 will be 20 comma 6. This will be equals to GCD of 20 minus 6 will be 14 comma 6. This will be equals to GCD of again 14 minus 6, that will give 8 comma 6. Again this will be giving GCD of 2 comma 6, right? At this point, see the difference. This is the greatest number. Now let's do the same thing again. So GCD of 6 comma 2 will be GCD of 4 comma 2. It will give GCD of 2 comma 2. It will give GCD of 0 comma 2. So there is a slight rectification which I have told you before, that this should be always positive. No, it can be 0 also, right? But it will never be negative. That means A can be equals to B. The difference is 2 minus 2, 0. Then 2, right? So when one of them converts into 0, the other value will be the GCD, right? So GCD of 38 and 6 will be 2. So you might be thinking that it doesn't look like an optimized version, right? So to find GCD of 38 and 6, we are going for GCD of 32 and 6. Again we are subtracting 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 6. Until there is a stage that we cannot subtract 6 from this number. So it still takes a lot of calculation, right? But can I say that we can reduce the whole thing in a single operation? What is that operation? Can we write something like GCD of 38 and 6 will be GCD of 38 modulo 6 then 6. So what is modulo 6? This will be 2, which basically means we are actually subtracting 6 as many times as possible, and then there comes 2. We cannot subtract 6 from 2, right? So basically we are removing all the 6 and we are taking the remainder, that is 2. So for programmers like us, we will utilize this GCD formula, but not in a direct way, right? So GCD of A comma B will always give GCD of A modulo B comma B. But I would say it will actually give GCD of B comma A modulo B. Why? I'm keeping the first value greater. That's it. Here I am keeping the first value greater. B will of course be greater, right? So for GCD of 38 and 6, it will be GCD of 6 and 2. See what we have written here. It's GCD of 6 and 2. And again, we will go for this same action, right? We are actually reducing 6 by 2. Like 6 minus 2, 4, 4 minus 2, 2, 2 minus 2, 0. But instead of this, I can write GCD of 6 comma 2 will be GCD of 2 comma 6 modulo 2. It will give GCD of 2 comma 0. And we found that the smallest number, that is b is equals to 0. That means your answer is A. So that's how you're going to solve this, right? So now you got this algorithm and you got to know how we are utilizing Euclidean's algorithm to optimize it, right? So in short, before we used to go for of minimum of 6 and 38. In this case 6, but 6 can be big also, right? But when we go for this algorithm, it will be GCD of 38 modulo 6. It will be GCD of 2 and 6. This will give GCD of 0 and 2, right? So see, one step, two step. So within 2 steps, we got the answer. But there can be more than 2 steps also. Since we got the 0 here, we can stop here itself. But the main point is that it's way lesser than minimum of these two, right? So let's implement this in code. So we are going to write a recursion code. You don't have to worry because we are using recursion, but it's a simple recursion. So let's write the code for that. Int a comma b, taking the input for a and also for b, and then I'll be like answer equals to get GCD of a comma b, and we'll be printing the answer. And we are going to create a recursive function of get GCD. Int a, int b, it's going to accept two integers and the return type will be integer itself. So here a is greater and b is smaller, right? So we will be checking whether b is 0 or not. If it is 0, return a. We got the answer, return a. If it is not, we will be returning get GCD of b comma a modulo b. Why b comma a modulo b and why a modulo b comma b is not there? Because while we are passing, we are keeping this in mind that the first value is greater, and that's the reason we are checking for b only, whether b is equals to 0. If b is equals to 0, we are returning a. If it is not true, minimize these values and go and check again. If still it's not true, go and check again. If still it's not true, minimize and go and check again. So there will be a time when b becomes 0 and then we will return a. So that a will be eventually stored in the answer and we will print the answer. But you might be thinking, okay, we are passing a comma b, right? So here also we should maintain that the first value should be greater. Yes, you're right. So we will pass the maximum of a comma b as the first value and minimum of a comma b as the second value, right? So now problem solved. So now let's run and see what the output is. Let's give 4 and 10 again. Let's see what the output is. Yes, the output is 2. Let's give 4 and 12 this time. Yes, the output is 4. I know this function looks slightly complicated because we are passing a and b, and then for the second iteration we are passing b comma a modulo b. Why? Because a modulo b will always be smaller than b. So that's the reason we are keeping the bigger value at first and smaller value at second position. So that's the reason we are passing bigger value at first and then the smaller value. So always b will be greater than a modulo b. So that's it for today. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.